The Hindenburg, the blimp from the 1930s that exploded because of hydrogen touching oxygen in the air, is what we're going to look at right now. The chemical reaction between hydrogen and oxygen. So let's take our atom tiles card and let's take some hydrogen atoms. Here's a hydrogen, here's a hydrogen, and two more hydrogens. And so we're going to make H2 and another H2. And then we need some oxygens. So we'll get two oxygen atoms, which makes it a molecule. So we have one molecule of H2 and another molecule of H2 and another molecule of HO. We need some plus signs, the reaction symbols. And so we're going to add these two together. And then we need the actual reaction symbol. Now, in order to make a chemical reaction, we know that all of the atoms on the left side of the equation, which are the reactants, still have to be there once the chemical reaction happens to produce the products. So we can't take any new atoms and put them in to the equation. So all of the atom tiles that are left or that exist out there in the world have to be on this atom tile card or out there somewhere, but not in this equation. So matter can't be created or added. Matter can't be destroyed or subtracted. That's the law of conservation of mass. Sometimes we call it the law of conservation of matter. Sometimes you might have heard of the law of conservation of energy. It's all the same thing. It's the law of conservation. So that means that what happens with the atoms is we just have to rearrange them in a different way to make new molecules on the right-hand side of the equation. So this is where the reaction happens. So we're going to take an H and any other H atom and an O atom, and what does that make? H2O, or we could arrange it this way, and that makes one molecule of water. But is that it? No. We know that water was falling from the sky with the Hindenburg. That's just one molecule. There had to be a lot of molecules of water falling from the sky to feel the water. So it looks like we have another H, and another O, which makes even more water, another molecule of water. So we can put that over on this side and a plus sign. So we now end up with two molecules of water as a result. This is the product side of the equation. What did people experience? Water falling from the sky underneath the Hindenburg. This now gives you practice rearranging the atoms and seeing that you can't add any atoms, you can't subtract any atoms. So every time there is a chemical reaction in a closed system, all of the atoms will still be there from the beginning to the end. We just change them up, switch them up, rearrange them on the other side of the equation. Now let's test and see how well you understand this and can do it on your own.